Hi everybody, good morning or good afternoon. Welcome to this webinar. We have people connected from South America, North America, all over Europe today. This is our third webinar about Centreon 20.10, our latest software release. I am Pierrick Martel, in charge of product marketing here at Centreon at the headquarters in Paris. Today, I'm joined with Samir Brizini, who's a product manager, and we
Hello,
will
everyone.
walk you through artificial intelligence and machine learning, how we are implementing such algorithm using a cloud-augmented architecture. So we'll, do a deep dive into some very technical considerations about anomaly detections, one of the implementation that we have, and then we'll look into how it is implemented in Centreon, how to use it, and we'll discuss a beta program that you can join. So stay to the end to have your questions answered. You may ask your questions at any time during Samir's presentation using the question tool box on the right-hand side on the GoToWebinar tool. And I will read these questions at the end so that Samir can answer them, hopefully. Okay, well, let's start. Samir, that's for you to explain us.
Thank you, Pierrick. Well, first of all, hello, everyone, and thank you so much for joining us. As Pierrick said, pretty much from all over the world. It's a pleasure to do this with you today. First of all, let's start with a bit of context. If you have been able to attend previous webinars, especially regarding version 20.4, we introduced for the first time our cloud platform, which is the extension, basically, of your on-premise platform that you already know and use so much. And the idea for us was to give your on-premise platforms capabilities, extended capabilities, thanks to our own platform that we operate for you. So if we have a quick look at what this platform does for you today. So it complements, as I said, your on-premise platform. And one of the things we do for some of our clients today is, for instance, we have a health check service where we operate regular checks on their platform and see if their Centreon is well fine-tuned and operating within nominal parameters. If you have been following our latest news regarding the MSP edition that came about just a few weeks ago, well, one of the features of this new edition is that we have access to dynamic invoicing for our clients. Basically, it's a pay-per-use system. Well, this functionality is served by the Centreon cloud platform, for instance. Obviously, one of the other capabilities is the machine learning, and the first of which being anomaly detection, for which we are here today. It also is the platform that allows us to deliver your licenses in a much more dynamic way. Instead of having the old fingerprint exchange and everything, now you can give access to your platform to our Centron platform, and then you just require what are my licenses, and you get them back. It's pretty much the same with the plugin pack library, which allows you to have online access to these services instead of doing them manually. And finally, we are working on an extension of these online services in order to give you access to self-care portal. So this is in design at the moment, which in the near future, coming year, would allow you to manage all your licenses, your platforms, and your billing and everything else. So today we are here to talk about machine learning capabilities, and the first of which, as I said, is anomaly detection. So let's get into it, and let's go into a step-by-step discovery of this new feature. So we'll go through this in a very progressive way. So the first step for us would be to cover the basics of what is anomaly detection, and then we see how it operates within Centreon, and finally how you can have a taste of it with the beta program Pierrick slightly introduced earlier. So let's get into it and let's talk about the basics. Anomaly detection 101. How do we define what is an anomaly? at Centreon, the way we define it is an anomaly is a deviation from a previously seen and thus expected behavior. In this, you have pretty much everything summed up. So if we go a little bit deeper, what we mean is performing anomaly detection is looking first into the past, seeing what there is there that we can then use to predict the future, and finally compare this prediction of the future in real time with the present we encounter. So this is basically the three big steps that allows anomaly detection to happen. So let's get to it with the first one. So looking into the past. In order to illustrate best this aspect, I've just grabbed from our demonstration platform, so demo.centreon.com, that allows you, to just have a look at what we're doing and what we already do. And so I grabbed, for instance, this metric. So in our case, I'm just using a number of connections from on a firewall in Brazil as an example. So starting off, we need to redefine exactly what are the tools we are working with. In our domain, which is the monitoring, we are mainly using here time series. So basically, this figure I'm showing is a representation of three main things. A metric, so as I said, this is the number of connections on the Brasilia firewall, which is our example. And then for each metric, we have two things. First, we have a datetime component, which is basically a timestamp usually, and a value which qualifies what was the state of my metric at any given time. And on top of that, you have what I just gobbled up together as metadata, which gives usually context to the metric, the unit, for instance, of its value, or the host it was collected on, or etc. So the first thing we do when performing an anomaly detection is collecting the historicity over a period of time. So for our example here, I grabbed 7 days, and I'm going to use these 7 days on the same metric to build our first anomaly detection as an example. So first step, we collect some history, and in this example, we have 7 days. The next step is to complement this data we have with pertinent variables. So now we're going to start in the learning part of our presentation, which is if you're familiar with everything going in the data sciences and machine learning, for instance, you already heard of this term, which is called feature engineering. So what is hidden behind this world? Well, quite simply is, as I said, giving context to the data I have available. So in our instance, a feature engineering can be, if we qualify this matrix we have, it can be saying of this period we have between the 25th and the 26th, well, it's called the Wednesday. This is a feature we're adding on top of our data, which is saying something about it from the timestamp, which has another value. And for instance, we can go about and specifying more features. For instance, we can say this period here where not much happens, where I have very low values, well, it happens to coincide with what we call a night time. Also, this long period over which there is almost no activity as well, well, it's called the weekend. And these are examples of features. Now I can also about qualifying the high activity periods and say, oh, these spike areas are called office hours, by the way. And so the idea is, while I am preparing for the anomaly detection to be performed, then I am laying the groundwork, which is giving as much context, well, to be more precise, as much pertinent context as I can give to my data. So this is what we call feature engineering. So now that we have enriched our timeline, what we do is we move to the next phase. And for that, the way we assimilate these new features, well, it becomes a new component of my time series. Basically, if you look at the time series, it's just a new column. I had the first column, which was my timestamp, my daytime, and then the value. And now I'm adding new columns saying, oh, by the way, while this was happening, it also was a Wednesday. It also was an office hour or a nighttime, or etc., etc. And all this is used as the raw material to perform the next step, which is the prediction of the future. So the way we do this, what do we mean by looking at the future? Well, to do that, what we do is we look at statistical correlations between the value we observe and the features that may have contributed to determining this value. And this is where the magic starts to happen. This is where all the work is done. And this is done by what we call the algorithms. So this is where the real machine learning in itself starts off. So we have this enriched historicity that we feed into the algorithm. If you are interested in the field, as I said earlier, you may have already heard of a few examples of algorithms. In our field, for instance, few algorithms that are used, we are named Profit, for instance, or XGBoost, or there are many others. If you follow the news very lately, just yesterday, there was an article on the New York Times that I found preparing for this about GPT-3, which is an algorithm working with textual analysis, which is not used in our field at the moment, but it speaks to the engine behind under the hood. And so one thing to know about the algorithms is they are the product of really dedicated research lab. For instance, Profit was designed by Facebook. GPT that I was talking about was designed by the OpenAI consortium. So these come out of huge laboratories, and this is where all the magic happens. So we take this algorithm and we feed into them the data we have earlier. And that's what we talked about, the datetime, the value, and the features we enriched upon these. So the next step is to run the algorithm with a set of hyperparameters. So the hyperparameters are what allows me to define this generic algorithm, to refine it to better suit my use, my need. And for instance, the horizon, the prediction horizon is one example of hyperparameters. And as an example, the prediction horizon, just in layman terms, is how far into the future am I looking to predict my events? So if we take this example I have a history of 7 days. Using this history of 7 days, how far into the future am I looking at? Is it 2 days? Is it 1 week? Etc. etc. This is an example of a hyperparameter. There are many different types of hyperparameters. They are very important. Some are very specific to the algorithm you're using. Some are generic, like the horizon. The salient thing to remember is I have an algorithm. Let's say I'm choosing Profit. I have a set of parameters I am choosing. For our example, let's go with a 2-day horizon of prediction, and I have an available history. When I run all these together, that's what we call a model. So now I have this context I have set up, and I'm training the result of it, which is a model. And the way the model goes about its inner workings is, well, it takes into account the various features, and that's why earlier I was saying you need to choose the pertinent features. So it looks at the different features, and it tries to weigh the different possibilities and say, okay, for instance, is the value of my metric more impacted by the fact it's a Wednesday, or is it more impacted by the fact it's an office hours, or is it a combination of the two? Is it more impacted by the weekend? And so that's the role of the model. It takes into account all these different variables, features, and try to find the best way to explain a value based on a combination of these features. So that's the work of the model. That's how the model works. Now that we have trained this model, the idea is to get a sense of, okay, the model has been able to weigh the different features, and now it's able to say, okay, by my determination, with the parameters, with the context I have. So as a reminder, the context is algorithm plus hyperparameters plus history. With the context I was given, this is my best explanation about how the value is determined. And in our example, it would say something like, okay, around office hours, I'm expecting a value oscillating somewhere around 140. Around slow activities periods, which are basically nights and weekends, well, I'm expecting a value somewhere around 20. So this is an example of one result of the model. Now the next point is to test this model. And the idea of testing a model is to validate the result it is giving. And the way we do that is we take a bigger period of time. In our example, for instance, and this is just to be able to best illustrate my point, instead of going about 7 days, I've chosen a period of a month, because the one thing the model will be looking for as it weights the impact of each feature is the cyclicity, for instance, behind each feature. So if I want to be able to take into account, let's say, the impact of the weekend, well, I need many instances of weekends so I can, put a weight on it and see, okay, so usually when I see a weekend in the past, I can expect this type of behavior. And the same goes about every feature. And this is the first impact we can see of the hyperparameters on the history. If I want to predict something a year from now, then I better have many years as an example, so that the model can extrapolate and say, okay, from the many years I've seen, I can say a typical year looks like this. So now I want to test my model. I want to make sure my model is pertinent enough. And the way we do that is we split the time period in half, in two periods, not exactly half. They're not equal in time, and say, okay, this first period, I'm going to call it the training set. This is the actual set I will be giving to the model as a context. So algorithm plus parameters plus history. This is the history we're talking about. I will be training my model on this period of time. And the idea is to then test this period of time on the next set, which is obviously the test set. And the reason we do that is we're trying to score the model to see how good it is at predicting the future. And the way we do that is we try different combinations within the same context. For instance, as I said, I've chosen profit and 2 days of prediction and many other parameters over this period of training. Well, let's change a few of these parameters and see if we get better results. And so usually when you say, I trained a model, what really happens is we try different combinations and see which one is the best. And to determine which is the best, this is where the scoring comes into play. So if you're familiar with the jargon here, this is to reduce overfitting. So it's an important term that basically says you don't want your algorithm to be exactly precise over the training period. Like it can be very, very precise in the past, but very lousy at predicting the future. You want your algorithm to find this nice equilibrium between I understand what happens in the past, what impacted the past, but enough to have an ability to predict the future. So this is what we call reducing overfitting. And so now that we have looked in the past and we have predicted the future, well, the next step obviously is to compare this prediction to the present. So here we are from the prediction taken once again from our example on our website. And the first thing we will do is set an acceptable deviation. So the idea is, as I said, the algorithm, we say, I expect something around 140, for instance, during office hours. Well, how tolerant am I to deviations from this expected value? Well, that's what we call the acceptable deviation. Basically, it will give us the size of the envelope in which we agree that the metric evolving within this range is acceptable. This is the first step. And now what we do is, on top of this, we collect in real time the data, and we see it point by point whether it fits within this range we have established. So how do we go about it? Well, it's quite literal, actually. If we take, for instance, this period of time here, we can see that the real data here in the middle is within range. So the resulting analysis is there is no anomaly, which is green on our screen. Now, if we take another example, here we can see that the actual data came out of the expected range. So the activity, for instance, since these are our working hours, the activity started a bit earlier than expected by the model. Well, obviously, this is why we have here a period of time, an anomaly raised. This is the module saying, the model saying there is an anomaly here. So this pretty much covers the basics, the anomaly detection 101. So now the idea is to see this anomaly, how it is implemented in Centreon. So,
and I hope everything you explained, which is very detailed and complicated, will be fully automated somewhere in Centreon. hopefully.
Yeah, exactly. So that's the idea. The idea is this is, as I said, what happens under the hood. What we do is we package all this for you, and we abstracted all the difficult parts and all the technical parts, the hyperparameters and everything. And the result for you is to use a module. The packaging takes the form of something you already know as Centron users, which is a module that you install just like any regular module you already have maybe done several times. And obviously, it's fully documented and it's available on the website. Um, but this comes with a few requirements, obviously. For instance, you need a version 20.4 or above. You need to be able to set up an outbound stream to our central platform, obviously, since that's where the calculation is done, and to be able to communicate with the platform, to establish dialogue. Well, you need an access token, obviously, and this we'll cover in the last part. So at this point, I have been able to install the module like anything else. Now let's see how this module interacts, how using the module in a day-to-day basis goes about. Well, the first step is to use the module to declare my new services within Centreon, which is a dedicated service created within the module, which we call an anomaly detection service. It's like any other service within Centreon, which I will show you later on, but it is created within this module. So I select a metric on which I wish to apply the anomaly detection, and then at the moment I have validated this metric. Well, the connection I previously established with the central platforms comes into play, and only the data regarding the metric. So this goes back to what I shown, the time series with its description, metadata, and its actual values. So this is live streamed to our central platform. So for those who are familiar, this is using another usual tool of Centreon, which is the stream connector. So now that the data arrives in our platform, well, everything I explained before is done for you. So everything, whether it is the history span or the horizon, everything else, all this is prepackaged for you, and the magic happens within our platform. And then what happens is your own platform establishes a dialogue. So this goes back to an important security features, which is dialogue is always outbound from your perspective. Your platform connects to our platform and requires about the available forecast. And the way we do this is, even if you connect every day to retrieve the available forecast, the forecast has a span of 48 hours. So the idea is, if for any reason you lose connection or something, or you miss a forecast, well, you still have in the bank 24 extra hours available, so that whenever you reestablish within 2 days your connection, then everything will update back to normal, and you won't even see any rupture of service and everything. So this is to lessen the dependency between your central platform, your Centron platform, and our central platform. The last part, obviously, then is to activate the anomaly detection using the usual tools you know, which are statuses, alert status, notifications, and everything within Centrion. So for the next part right now, let's go into these. Let's start with this first part, which is how do I go about using the module, since everything else happens under the hood. So for that, let's go and look at the module in action, and let's go to the demo. So I have prepared the demo right here. For those who are familiar, this is taken straight out of our website, which you have the demo available. And for the purposes of the demo, I already installed the module and everything. If you have any questions and you are curious about how easy it is to install the module, just as to give you a hint, our experts and all the other users will do it in about 30 seconds to 1 minute. So it's really straightforward, very well explained in the documentations. So feel free, it's already available to everyone, so you can have a peek and see how easy it is. So now we are interested in using the module. So for that, I want to configure my new service. And as I said, it's a kind of service, which is anomaly detection. So this, I can just go into the menu and say, I want to add an anomaly detection. Okay. Very few options. First one is the description of it, the name I want to give it. So this is, for instance, my test service. This is the host service. For instance, if I want to recreate the example I gave in the first part of the presentation, I want the number of connection on the Brazilian firewall. So this is where it happens very easily, everything listed for you. And then you have the same options you are used to using into Centreon, which are alerting options, notification statuses, and everything else. The last part, obviously, is to validate, save your settings, and then redeploy the configuration. This is something you know already, are familiar with, I guess, within Centreon, and that's it. So this is how you create a service. It very much looks like what you already know. The only difference is the nature of anomaly detection makes it useless to use parameters such as thresholds and everything. This is what the anomaly detection does. So that's why you don't have to configure these parameters. And so the next part for us, well, to see how our prediction fare in actuality. So after I saved the settings for my new service, what happens is your Centron platform immediately declares this new service to our central platform and starts streaming the data. And using this data, our central platform every day will do two things. Either it will create a model and train it if there is no model already, or it will monitor the scoring of the model and retrain it if necessary. And the result you can see right here. So let's go about testing. All right, so I'm going to take a period of time that will be more suitable to see the results. And here I have the results. So this is, for instance, the predictions we have running on the demo. And you can find, obviously, the Brasilia example I was using earlier, and there are many others. So a few key things to watch here is, first of all, the correlation between the deviation from the acceptable range and the evolution of the status. So this is the model saying, okay, to me, there is a problem here. And this is reflected on the graphs in front of us. And we can see here different kinds of metrics. So in these two metrics, in the three metrics, actually, we have a time-sensitive cyclicity. So basically, we have activity depending on the hour of the day, working hour, nighttime, and also on the weekends and everything, as I shown earlier. Now, there are other things that the model is able to determine. And as I said, the magic happens where you don't need anymore to worry about setting your thresholds manually. This is where it's supposed to happen. And in this example we have, well, the model did not find any cyclistic pattern, but it did find that there is something usual expected about the metric. It's always around a same value. So the envelope, the acceptable deviation, is very well bound between these two values. And so the model will define as anomaly if the real-time values come out of the expected value. And we have the same example here. So what it shows essentially is it really replaces the mental exercise we all do when configuring our thresholds. It does it for you. That's the whole point, and this is the direction we try to give it, which is abstract as much as possible the 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 thinking we do in our heads, which is, okay, I have to anticipate how my metric is going to evolve and everything, and choose it manually. This is what the anomaly detection is doing for you. So back to our presentation. This is, in effect, how easy we're trying to make the adoption and the using of the module, and how effective it can be in showing deviation from a pattern. Now, if you want to have in hand into this, we have a beta program running. It's been running for a few months now, and it's been in a very closed phase with very few users participating with us because we were ironing out a lot of details, important details. And now we are willing to open it to more participants and together make it the best feature possible. So if you are interested in how monitoring will be impacted in the future by everything AI powered. If you want to satiate basically your interest in this, well, you come with us and see how it is done. If you are curious about how Centreon is going about implementing it, this is, as I said, this is something, a trend that is not just unique to Centreon. The market is going there. If you are curious about, okay, how is Centreon going about including this? How are they implementing it? How are they successful in abstracting the huge number of parameters that can come into play? Well, this is the place to come and see how it's done. But more importantly, this is where you can have your say in how we do things and in what order things should be done. So basically, it's to say, this is a very great opportunity for you to point us into the right direction. And I have enormous thanks to give to the users already in the program and that have been helping us tremendously to make this really a leaner experience for all the users that will come later on. So this is very much almost the most important part for us. There are so many ways of successfully implementing AI and machine learning in any solution. There are so many ways that have been unsuccessful, and we want to make sure this opportunity we have is successful because it best fits your needs. And the best way to do this is for you to participate into this. And also, well, we try to make it as easy as possible to come into the program. So it's really a 5-minute procedure, which starts off with filling out a participation form, which is very straightforward, asks very direct questions, which are, for instance, obviously the company name, your name, how we can contact you, your preferred language. Our team are very fluent in English and French, so feel free to choose the language fits best your abilities. And then this is a very quick section about the hard requirements we talked earlier. Are you able to set an outbound stream? Do you have, or are you able to deploy a 20.4 at least version of Centreon, etc., etc. And finally, this is how you want to collaborate. How often do you want to participate? How using what means? For instance, we have clients we are talking to every week, some others every other week, and some others every month. So this is made to best fit your needs and your availability and make your participation absolutely hassle-free and just, productive for you and for us. And so after that, finally, you receive your token, which is the access token we mentioned earlier, which is the only way at the moment you can get access to the anomaly detection and start using it and, going back and forth with us, helping us improve these first feature of the machine learning and the AI possibilities given with the modern tools. And as I said, this is just the first. Anomaly detection is just the first of many features we hope to come into our solution. For instance, we can give a few others that are already in the works, and we hope to include into the program very quickly. The first of which is very well worked out at the moment, which is capacity planning, which is the ability to predict how soon into the future any capacity-driven service, let's say a hard drive or a cluster, will reach maximum capacity. So this is one of them. The next one we are working on already is the outlier detection. And this is a very important one for our users, which is nowadays many solutions you monitor with with Centreon are based on cluster abilities, which if it is configured well, you have your cluster dispatching the load of work between many nodes, for instance, and if it's doing it well, it is dispatching it in an even way. So you expect all the nodes of the cluster to behave in a pretty much similar way, and this feature aims at giving the ability to watch for rogue agents within the nodes and say, okay, this node is not behaving in the same way as others. So then I can take remediation actions and everything. And these are just a few examples. Obviously, as I said, this is really important for us to have a discussion with our users about it because there are many options of a whole set of features we can include. deciding what are the pertinent ones and in what order they should be implemented. This is something we want to do with you. And this is why we really hope you can join us in the program and help us make it the best feature possible. Thank you, everyone.
Well, thank you, Samir, for all these detailed explanations and the tour of how to do it. It's now time for questions, and you can still ask your question. I have two very similar questions about licensing. We have an open source version of the platform. We have IT edition, business edition, MSP editions, which are commercial edition. Which one are applicable to the beta program?
Okay, well, regarding licensing, the beta program is available to all forms of Centreon. So whether you're on open source, IT, business edition, or MSP edition, you can join and participate in the program. Now, I guess behind this question is a question of how it will be commercially available later on. Well, that's something we still are thinking about, and it's actually one of the talks we have with our users, which is how can we best make this available to you, and how can it make the best sense for you in a financial way, and for us in the same way. As I said, the magic happens within the central platform, so obviously this bears costs, and the idea is how can we best package this commercially that it makes sense for the users and for us as well. So we're still thinking about it.
All right. I have a question about business activity monitoring, our service mapping feature. Can anomaly detection be added to BAM or be used in conjunction with BAM? You talked about some metrics, but how can I mix business activity monitoring, a BA, a business activity, and anomaly detection?
Well, this is actually what we are working on at the moment with our clients. So the goal, and this is our strong will, is to make any service coming from the module as transparent as and using the same parameters and artifacts as every other service within Centron that you know. And the idea is we're working on the integration at the moment so that you can use anomaly detection on every form of services, including business activities. So that we are working on it. It will be included within the module by the end of the program.
All right, thank you. I have a question, which is maybe two questions. The notification process is integrated into service definition. Will it be possible to choose anomaly detection in replacement of the old traditional method? I guess there's two questions here. Is first of all, is our regular notification process, sending an email or a text message, still applicable as usual? And the second question would be, in the future, I guess I would like to choose for a service or metric, just between critical and warning fixed thresholds and anomaly detection, as easy as that.
Okay, so for the first question is, yes, definitely. You can use every tools already available for normal services is available to anomaly detection services. So yes, statuses and notifications are configured in the same way. Regarding the second question, which I believe, will it be easier in the future, just to switch from threshold to anomaly detection?
Yeah.
Well, this is the second part of the work we're doing with the users, which is besides making it work perfectly, how can we make the integration of the service of the module within Centreon as lean as possible, as comfortable as possible for our users? And yes, this is something we are working on. At the moment, it is a separate, as you saw on, it is a separate menu that allows me to create my anomaly detection services. Yeah. In the end, we hope to make it as easy as just flipping one feature and saying, okay, I don't want to use a threshold. I don't want to use many thresholds. I want to use anomaly detection.
All right, good. That's what we want.
That's
A question about feature engineering. How does feature engineering works automatically for every context? For example, banking holiday day, which is not a national holiday. How do you do that?
So this is where a huge load of the work is done by our team. And we just had this question with our last workshop with a client participating in the program. which basically they have a change of time in their time zone, and so everything shifted by an hour, for instance. And then they have their own holidays, and on top of that, they have their own planned disruptions. And so we were working on how can we make this as lean as possible. So to answer the first part of your question, Pierrick, yes, using your own time zone, for instance, to extrapolate holidays, etc., is something we wish to make as easy as possible and automated if possible, which is there are many databases out there describing what is an off day in what time zone. We hope to use these so that it is taken into account by the model. Now, the next part of the answer is, at the moment, we are doing it with our clients. So we're working on a feature that would allow the client basically to provide a calendar, and so we can feed it into the program so that you don't have to, so that it does take it into account. This is all in the works. It is not yet available. This is something we are talking every day in the program. So yeah, we know it can be a hassle. We're doing everything we can to abstract it for you.
All right. I guess this is why we have a beta program, is to figure out all of that. And
to be honest,
make
this
it
is not
easy.
something. Exactly. To be honest, this is not something we prioritized when we first developed the module before launching the program, and very, very shortly after starting the program, it came about.
Yeah, that's the reason for beta programs.
Exactly.
Thank you. You can still ask your questions. We have a few minutes left, 3 minutes, I guess. There is one question about after I've installed my module and inserted my token and configure my service, how long will it take before I get my first prediction? Is it a matter of days or weeks?
So, two cases. You already have the data available on your platform, for which case we have developed a script that allows you to force the sending of the history you already have available so that you don't have to wait any time. It's just the time for you to send the history you have available, and then we can start predicting on it, based on it. Now, if you just started monitoring a specific service, then it all depends on how the service is behaving. As I said earlier, if your service is impacted by a weekly cycle, then you have to wait many cycles, which is many weeks in this case, to have something reliable. If it's many days, then that's the way it is.
All right, good. I still have one question, last question, is do you confirm that you also detect when a metric goes to 0 and should not?
Yeah, exactly. So to remember what we said about the basics of anomaly detection, if from seen behavior in the past, the expected value is different than 0, and all of a sudden you have a drop to 0 for any metric, then it is clearly a deviation from what has been seen and what is expected. So it will raise an alert indeed.
Okay. How would it take in planned growth of utilization? Like I have web shop and I'm launching a big sales campaign. I can predict that growth come. So I'm not too sure I understand the question.
I think I do. I think I do, which it goes back. It relates to the question we had earlier about how can you predict off days depending on the time zone and everything. And the example I think the user is putting forward is one we have with one of the participants in the program, which is they know, for instance, at every end of the month, it's not always the same day, but they know they have all the billing that is performed, and so they have huge calculations going about in a vague period. And so we are working on, if they are able to give us beforehand a calendar of an agenda of when things are going to happen, then we're working on integrating them into the model. The model is already able to do it. Now we just need to find a way to introduce from the client to the model so that it takes into account this high expected activity time or low activity time, etc., etc.
All right, good. Well, it's time for this webinar to end. Thank you everyone for participating. If you have more questions, just join us, and we'll be happy to answer them by mails or calling you. Thank you very much. Have a good day, all of you.
Thank you,
Bye-bye.
everyone.